Okay, first thing that we have to do is graph the system of equations, and here's what I did. Sorry that I didn't talk. I was too busy graphing this, so apologize for that. So we find our slope, find our y-intercept, and here it is, and that is the first one. The second one, here's our slope and our y-intercept, and we graph that one. So here's our two lines, there and here, okay? As we did that, okay, we graphed both of those, and so now it says identify the slope of each equation. And what do you notice? So the graph of the slope of the first equation is negative 2/3. The slope of the second one is negative 4/6. And what do we notice? They are the same. Okay. Next, it says identify the y-intercept of each equation. In the first equation, the y-intercept is 4. And in the second, it's negative 3. It says, are the y-intercepts the same or different? Well, they are different. Okay. Well, next it says graph the system, y equals 2x minus 5 and y equals 2x minus 1. Again, I'm going to be a little quiet while I graph this, but you should know the slope for the first one is 2/1. The y-intercept is negative 5, or 0 comma negative 5. And the second equation, the slope, is 2/1, or the b is negative 1 and 0 comma negative 1. Okay, so here we go with that. We have negative 5 and negative 1. And I'm going to do those, so it's going to be a little quiet while I graph those. Okay, so now I graph that, and that's what it should look like. So it says identify the slope of each equation. So the slope for the first one is 2, and the second one again is 2. Okay, and again, they are the same. Then it says identify the y-intercept of each equation. And the first equation, it is negative 5. And the second equation is negative 1. And again, they are different. Okay, so next. All right, so next, it says, what did you notice about each of the systems that you graphed? Huh? They are parallel lines. Next, it says, what did you notice about the slopes of each system? They are the same. So then it says, what did you notice about the y-intercepts of the equation in each system? They are different. So here, it says two distinct nonverbal lines in a plane are parallel if they have the same slope. If two distinct non-vertical lines have the same slope, they are parallel. Next, it says, suppose you have a pair of parallel lines on a coordinate plane. In how many places will those lines intersect? None. Suppose you are given a system of linear equations that graph as parallel lines. How many solutions will the system have? 0. No solutions. Write an example of a system with no solutions. You can write as many as you want, as long as that you have the same slope, but different y-intercepts. Okay, there we go. Next, it says what we want to find out is how to recognize when the lines defined by the equations are parallel. Then we would know immediately that we have a system with no solutions without graphing. A system can be easily recognized as having no solutions when it is in the form of these two here. Guys, as I said, you need to make sure that you know what these are. This is vertical lines. These are horizontal. Okay? And therefore, these are parallel. So here it says we want to be able to recognize when we have a system of parallel lines that they are not vertical or horizontal. What characteristics did each pair of equations have? Well, they have the same slope and different y-intercepts. Okay. Next. It says graph the following system of equations. Well, here we can use our intercepts to graph this. So for the first one, x and 0, so x plus 2 times 0 equals 2. So x equals 2. So we have 2 comma 0. So 0 comma y, we have, sorry, let me put that in there. 0 plus 2 times y equals 2. So 2y equals 2. Divide both sides by 2. We have y equals 1. So here we have 0, 1. So let's graph that first. So we have 2, 0. And 0, 1. So and let's write it. Oops, 2y, sorry. Now to write the other one. So in here we have 2, 0. If you notice, we have those same points, okay? Which means, guess what? Same line. So I'm just going to label this with that same equation. Oops, sorry. Okay. So again, it says, what do we notice? Okay. Well, they are the same line. It's up here. Okay. So here we can also check if a system of equations has infinitely many solutions by checking to see if the equations are multiples of each other. So what happened was I can multiply this equation by 2 to get this equation. So to write an example of a system with multiple solutions, I can just take any equation that I would like. So for example, 2x plus 5y equals -3. And if I were to multiply this by, say, 3, I would have 6x plus 15y equals -9. And they would be the same equation, and they would have multiple solutions. So that ends this lesson.